Good morning, Yelm students. We are excited to host the Professionals by Pathway Career Exploration event to help students connect their learning to career opportunities. I am Ilena Wall and I'm excited to welcome Mr. Mark Rohwedder and Mr. Lance Rohwedder as our guests today. Before we get started, I want to remind everyone this is being recorded so future students can benefit from our speakers. And we have the next 30 minutes to learn about this career field, the education that is needed to enter and grow within the industry, and what advice has for our speakers have for our students. We will be monitoring any questions that students submit. So let's get started so our students can learn about various professions and how they can prepare for their future. Mr. Lance Rohwedder and Mr. Mark Rohwedder, tell us about your career field and like how to get started, growth opportunities, pay, and more. I think you have a presentation you'd like to show if you're up for that yet.
Sure. Yeah, go ahead, Dad. I'll just run the slides.
All right. I got to move something here just out of my way. Okay. All right. Well, everybody, my name is Mark Rohwedder, and I'm the Senior Technical Engineer, Electrical Instrumentation Manager for 3 different paper machines here at WestRock Longview. WestRock is a global pulp, paper, and packaging company. Has over 50,000 employees, 320 different sites in 30 countries. And what I was going to talk about today was really a career in engineering, but there are many careers at WestRock, ranging from just out of high school hourly production jobs to trade jobs to engineering, managerial, warehouse, you name it. We pretty much have it all. But we will basically be dealing with engineering today. All right, Lance, hit the next screen.
Sure. Oh, that didn't work. There we go.
All right, so this is just an overview picture of the Longview site. It is around 600 acres. We have 4 different boilers providing steam for our operations, 2 large Camure digesters that I'll talk about in a minute, and 5 paper machines that are producing craft paper here at the site. Okay, what we do is make craft paper, and we'll talk about some of those products as we go along through the presentation. But what we do to make paper is we take chips on that picture on the left of the screen. So these are coming from sawmills, or we grind whole logs up into chips. And the other source is, we're fairly big in recycling as well. So on the right is pictures of what we call old container board or old cardboard that you might recognize coming from facilities such as Walmart's or Fred Meyer's or Costco's, where people take old boxes from shipping and they get compressed into bales, and we buy those bales and we turn those back into pulp as well. All right, next slide. So this is a picture of 2 of our paper machines from an overhead view. They're fairly long. They're about the length of a football field in length or longer. And if you look at you moved ahead on me.
Whoops, sorry, didn't mean to click that.
It's all right, we're going to go there. But if you look down on the left, you see this brown substance at the start of the machine coming out of the head box. That is the pulp that we've made from either the chips going through the digesters, which is a large pressure cooking device to break the chips down into pulp, or we take the old cardboard, mix it with water into a big, essentially mixer or beater, and beat it back down into pulp as well. We take that pulp, we spread it out on a thin wire on the machine, and it makes what would be a very wet, thick paper stock that starts down the machine and starts into the press section of the machine. Okay, next picture. So this is just a close-up of the pulp or paper stock that's starting down the machine to actually make a roll of paper. You can see a brown there. Okay, as we go through the machine, we use the steam from all those boilers to heat big cans or drums. And the paper weaves through the machine. And I'm sorry I couldn't get a good picture of it because all the doors were down when I was taking photography the other day. But anyway, it just weaves through all these drums, and essentially we're drying the paper as it comes down the machine. When we get towards the end of the machine, we have a sheet of paper that you can see there. This is about 3/4 of the way down, and it's fairly dry at this point, and you can recognize it as paper. It goes through, at this point, a sophisticated scanner where we're scanning for impurities and strength and other properties of the paper. And then that's feeding a computer system and then making adjustments all the way back at the head end of the machine to make sure that we have consistent quality as we make this roll of paper. This is the end of the machine, and you can see the paper spooling up on a big drum here. And so we're spooling that paper up and making a huge cylindrical stack of paper essentially. And then we're going to cut that down into various customer widths and lengths in our winder section. All right, like I said, we have a extensive computer system that monitors pretty much everything on the machine. If you zoom in, you can see a large computer screen that the operators use kind of in the center. Down on the lower console is 2 other screens. We have a lot of different sensors and valves that are into this system, of which Lance actually sells a lot of those, and he'll talk about that in a little bit. But the opportunities from a job standpoint are, tremendous. We have everything that you need to make paper for pretty much every discipline in the engineering cycle. So chemical engineers play a high role, electrical engineers, computer engineers, structural engineers, mechanical engineers. It takes all those different degrees to make paper. And you'd think it would be simpler than that, but it's actually a fairly complex process as we go along. All right. So this is the finished product that we make here at Longview. They're just rolls of paper, and they're cut in different sections that will go off to various facilities, most likely box plants, where we'll make these into the boxes that you're familiar with, like from Amazon that you get on your doorstep. This paper is actually the outside and inside part of a regular box that you would see. Okay. So examples of a couple boxes. So this is the outer coating, and if you look on the inside, you'll see a smooth sheet on the inside as well. The paper from this mill is essentially making those 2 sheets of paper that go on the outside and inside of the box. At our sister plant up in Tacoma, they actually also make a white paper, and then you might see those on newer color TVs or wine boxes or anything that they want to have a nice color print. That'll be printed on white paper that they make in our sister plant in Tacoma. The other thing I could show that we're making now that's just a new product, if you can see it on the screen, hold it up. You can recognize this. This is a popcorn bag made out of paper, and that's coming off our number 5 machine here in Longview as well. We're making microwave popcorn bags now for several people. Other products that we make would be like cartons that you would see cans of Coke in. Anything that has a cardboard package, we essentially make at WestRock. So anything you go to the store that's packaged, there's a good chance that it's coming from one of our WestRock facilities. All right. So what type of engineers does it take to operate a facility like this? Say, can you guess? I gave you a clue earlier. Pretty much takes all types, but you want to hit this next slide, Lance? So like I said, chemical engineers making paper or just making pulp is a huge chemical process. In itself, it takes electrical engineers. We use a large amount of power. In a facility like this, it's around 100 megawatts an hour that we use. In the sister plant up in Tacoma, it's right around 40 megawatts an hour. So we're a large user of electricity. Mechanical engineers for all the steam balance and thermodynamics and the system for making paper, as well as just the mechanical integrity of the machines. And what other types of engineers or disciplines of engineers could you think of that might also be needed in industry to make paper, or any industry in general, even if it's like petrochemical or automobile or any of those? Next slide, Lance. So some different ones that you may not have thought about when you think of general engineering would be a safety engineer. In modern industry, safety is probably the paramount thing we focus on to make sure our people go home in as better condition than when they started the day at the facility. Environmental engineers, because all modern industry in the United States wants to be good stewards of the environment, make sure we're treating our air, water, well, air and water mostly, but those are the two main things that we want to make sure that we're not affecting as we make our product. We also have structural engineers as we make new buildings and facilities. And then the other one is computer network engineers. It used to be that a lot of our systems were hardwired. Now they're pretty much all computer-based, using Ethernet or fiber optic connections in connecting all of our various pieces of equipment in the facility. So most of the paper machine is one big fiber optic or Ethernet network communicating to all the various programmable logic controllers, the panels, the screens that you saw, the scanners, sensors, even into some of the valves and some of that equipment. So these are just a few of the type of engineers that we have here at WestRock and that we're looking for. And so I guess my question to you that are watching this is, what type of engineer do you want to become? What college are you planning to go to? And what actual jobs might you hold? So this is where I wish we had interaction with the audience right now, but we'll go along. You can be a design engineer where you're designing new circuit boards, designing new processes. You can be designing new equipment. So that is one level of engineering you can be. You can be a sales engineer where you're selling components or pieces. And Lance will probably go into that in a little more detail. A process engineer that establishes how we're actually going to make the product and the chemical process it takes to do that. You can go into management and be a supervisor, such as myself. You could be a project manager, similar to the people that are leading the construction of the new middle school there in Yelm. So there's various disciplines that engineering can lead you into for a career besides just engineering. So in modern industry, engineers hold a variety of positions. All the ones we talked about there, they also get into being the overall managers of the facility. A lot of the financial people are engineers as well.
All right. Well, I think I'm going to take over after this one here. Speaking of engineers, our new CEO for Emerson is an engineer. He's the CEO of a Fortune 500 company. So sky's really the limit. So I'm going to talk about a little bit different of an engineering path. So that's going to kind of be me. My name's Lance Rohwedder. I'm a mechanical engineer, I guess, by training. I don't do much of that anymore. But so I work for Emerson, more specifically the process management division. Emerson's a huge company. They make everything from ceiling fans to control valves to, you know, little home automation gizmos to make your life better. So I work for the instrument sales division here in Washington. I kind of cover most of Western Washington, around Seattle. So it's a little bit different of a path. So I'm going to kind of go over what that is and what that entails. So what do I do? That is a great question that I ask myself almost every day. So when you go into a sales role, it's a lot different. So I left the world of the paper mills and joined the sales engineering world. And it was a huge change. So essentially, I am in charge of a group of clients, and I make sure they're happy and make sure they have the newest equipment, help them spec out equipment, help them with their engineering designs, review their drawings, review their essentially all their plans to build new pieces of equipment using Emerson gear. What that also means is I have a lot of freedom in my job. I don't work 8 to 5. I don't work 9 to 5. I work when the clients tell me to work, essentially. So there's some days, like yesterday, I sat at my desk in my home office answering emails. And then there's other days where I'm out on site doing startups and helping the clients and seeing clients. There's a lot of face-to-face interaction in this job, a lot of talking, a lot of presentations. So that's kind of a gist. When you go into this type of role as an engineer, it's completely different. It's unstructured and it's kind of organized chaos when you get into it when you first start. So I'll kind of talk about some of the things I do and the things I sell and what industries we work in and go from there. So my main job, I guess, if you had to specify my title, is industrial instrumentation. So for example, I work for Rosemount and Micromotion. So some of the things we sell that help support different industries are the thing on the left is a Rosemount Anubar pressure based flow apparatus. All it does is measure flow in a pipe. Seems simple enough. You need to know how much flow is going through that. But that is actually a very complicated piece of instrumentation, and it's very expensive. That's one thing you'll learn when you get out of college is when you're doing projects and scoping things, stuff is very expensive in the industrial world. And I can kind of talk about that since me being the sales side, I know all that like the back of my hand. So next to it is a non-contacting radar is what they call it. So that's another thing I work with, and it measures level in a tank, something very simple. You need to know how much pulp is in a tank for a WestRock example. But then we also break into the newest world of wireless. So as you know, you have wireless in your house. It kind of runs our life these days. And it is now starting to go into the industrial world. So that's where network engineers come in. So we also employ network engineers. So we work with wireless. And then the micromotion side is all flow meters. And I'll go into some industries, but those can be, those Coriolis meters on the left middle can cost up to a couple $1 million per one. So to give you an idea, some of them are not cheap. Nothing I sell is cheap is what I'm told from all my clients. I'm expensive. So here are some industries that I thought would be kind of interesting. So I work in a variety of industries, all of them from like aerospace, Boeing, SpaceX, Blue Origin. I've been to all of those facilities. I've seen that rocket in the Renton facility. I work with the engineers at Blue Origin, help specing out fuel systems. So you get to see a variety of industries in this job. You're not just kind of stuck in one area. Probably our biggest client is oil and gas, helping them, make their product, make gasoline, diesel, rocket fuel, things like that. So we work a lot, and that's actually a picture of the Shell refinery up in Anacortes, which actually just sold. But that is the Shell refinery. So we do a lot of work with Shell. They are a big client. They probably spend 40 million with us a year just to keep us around. So big industry. Pulp and paper is also a big one in the Northwest. I cover 4 different paper mills here in Western Washington. Had no idea there were so many until I started this job. So WestRock, IP, some Georgia Pacific mills. I actually cover the WestRock Tacoma mill that Mark mentioned earlier. And then my favorite one to work in that I thought it'd just be fun to put on the slide that I can't actually talk about is I work a lot in nuclear these days. One thing you'll learn when you get into a sales job, you sign a lot of non-disclosure agreements. There's a lot of things that you can't talk about, which is kind of fun. You feel like you're on a secret mission or something. But a lot of stuff you can't talk about, and nuclear being one of them. But that is a picture of a modern, I can tell you that is a picture of a modern nuclear salt reactor. And that's how big it is. They're not very big. They're not the big ones you see with the giant cooling towers. So that'll be something coming in the future. And we work, and me specifically, work in all of these industries. So I am not just working in one industry or one plant. I have over 500 clients, all in different plants. So that is kind of an insight to what I do, and I help them by giving them the correct instrumentation and speccing it out. So I'm going to go in kind of more of what Emerson looks for when going into hiring, especially in STEM. So Emerson is a big proponent. We hire a lot of engineers and other things. So I made a little wheel here, talk about all the different degrees, and some got cut off for some reason in this. Those are all supposed to say engineer. But different type of STEM degrees at Emerson. So programmers, we use programmers every day. We have 2 that work in the Northwest. Mechanical engineers like myself. So mechanical engineers are mainly working at the factory or out in field sales to help support the mechanical installation or help spec our equipment. Electrical engineers, all of these modern instruments are controlled with either Ethernet, a 4 to 20 HART. They're all controlled with electricity. They're not pneumatic anymore, pressure based. So got to have a lot of electrical engineers. Chemical engineers, surprisingly enough, we use them all the time to help make sure that the chemicals that are going through these instrumentations are going to be okay and they're going to last. You know, if you want to go into a little bit different field, a 2-year degree or a trade school, we employ a lot of instrument techs. We have a team of 150 instrument techs in the United States that go around when something happens with our piece of equipment and it doesn't work. Manufacturing engineer, we manufacture almost all of our stuff in the United States, 90% or so. So in Boulder and in Eden Prairie, Minnesota, we have 7 different facilities, and you need manufacturer engineers to help facilitate all that. That's, wow, this slide got really messed up going over here. That's interesting. Anyways, that's supposed to say electrician. I don't know what happened there. A lot of electricians to help plants with their wiring. So we will do whole entire builds and build a plant for someone. So a lot of electricians. Welders, we employ about a mix of, funny enough, 50-50 human to robot welders to do all that, to build all of our equipment. Aerospace, we have a whole division dedicated to making aerospace products. Networking engineers, you know, the world runs on networks these days. You can't operate anything without it. And then metallurgists, you got to make sure the metals are compatible and that everything will work with whatever you're going to put it in. So these are just some type of degrees that are required to work for Emerson in different areas of the plant, or not the plant, the you know, the company. So that's just kind of some things we do. So this is when I was going to do some interaction, but you know, with the WebExes, it's always kind of hard. So I was going to ask, what are your current plans? Do some of you plan to go into trade schools? Do some of you guys plan to go into the engineering field? Do some plan to just go right in and become an apprentice as an electrician? All of these are great, viable options in today's economy, and they'll pretty much have jobs forever if you go into any of these fields. So in a nutshell, that was kind of mine. We have one last slide here. That was the last slide from yours, Mark.
Right. Hey, Lance, I mean, just talking about trade school a little bit, because, at WestRock, we employ all the trades as well, machinists, welders,
Yep.
electricians, instrument techs, carpenters, you name it. It might be interesting to know, and I'm not sure what Emerson's paying on your side, but at WestRock, with a little bit of overtime, any of those trade school jobs for a journeyman pay well close to $100,000 or more.
Yeah. So ours are all given a base salary, but it's base salary plus overtime. I had a instrument tech 2 years ago. It was a little slow last year. It doesn't count because of the COVID-19. He pulled in $140,000 as an instrument tech. So sometimes they make more than we do. A lot of times.
We had a
I know when
question
I
in
was
the
in
Q&A.
Tacoma, I had one of, oh, excuse me, what?
There was a question in the question and answer column. I can read it to you guys. They wanted to know, what level of education did you need to get the job you have now? Did you have to have just a bachelor's, master's? What kind of education did you have to get your job?
Well, you go ahead, Mark, and then I'll answer.
I currently just have a BS in electrical engineering. And so I started out myself as an intern engineer, became a process engineer, became a project engineer. From project engineering, I went into industrial management. Then I went into industrial maintenance management, and that's where I've pretty much been since the late 90s, early 2000s. So my job is essentially the maintenance side of industry, but all with just a bachelor's degree.
Great.
So I can answer it for myself. So I started out as a intern actually at WestRock as I was getting my mechanical engineering degree. Then I graduated with my mechanical engineering degree, and then I worked at WestRock for about a year or two as a project manager. And then I jumped ship and left to Team Emerson, which one of the requirements for my position was a mechanical engineering degree. But I'm in sales most of the time. So it's kind of a weird requirement. I use my engineering degree, here and there, but it was just one of the requirements to get into a job like this. So you could say that, yeah, my level of education is just a mechanical engineering degree. So it really opens all sorts of paths. Engineers, like I was saying at the beginning, the CEO of Emerson right now is an engineer. He has a master's degree in finance now, but that was a requirement so he could get the job. But he worked his way up through the ranks, started as a salesperson. 20 years later, he's a CEO of Emerson, making $10+ million a year. So sky's the limit.
Wow.
It is interesting. An engineering degree opens probably more doors than any other degree out there.
Yes.
And it doesn't have to be a particular discipline of engineering either. It's just having that engineering degree opens a lot of doors.
Yep. And it's interesting, like even if I look at our marketing people at Emerson, half of them have engineering degrees. They don't have marketing degrees. So it's really quite fascinating. It's engineering opens up so many doors that you wouldn't think of when you got that degree. A lot of people think of engineers, we sit down at our desk and come up with things or drawings and plans. I'll be dead honest, I've done that one time.
I guess I've done it a few more times than that. I mean, being a project engineer in my early days, designed and built a lot of different pieces of equipment, which was a lot of fun and a lot of satisfaction in seeing them actually start up and run. But, once, I got into management, that opens up a whole new realm of learning that, I wasn't, thinking of when I got my engineering degree. And the interesting part is, at least in my job, I still get to use a lot of my engineering on a day-to-day basis that maybe Lance doesn't get to use in sales. So I still go out and do programming. I still go out and troubleshoot circuits. I still do a little bit of design work. I get to have that daily interaction in my field, which is really fun.
Where I might get that once a week, where I get to go out and see physical installs and troubleshoot those issues. But one thing I've learned, and I'm sure Mark would agree, when you work at places, you're not just a mechanical engineer. You learn to be electrical, you learn to be civil, you learn to kind of do it all, because if you don't, you're going to be sitting there waiting a long time for some help. So it's one degree, opens doors for a lot of different things to learn.
I guess that's really funny because as an electrical engineer, no matter what breaks in a facility, it's always 100% an electrical.
Yes, it is. It's always your
Until you
guys'
prove
fault.
it's not.
Oh, goodness.
Never
And most of the
mechanical.
time it ends up being a mechanical problem, but we have to go out and
Great. So we're at about the end of our time, and I would like to thank you both for joining us today. It was very interesting about learning about your jobs. I had no idea. I mean, what engineers do and all the different kinds of the different things that they do. So it's very interesting. So I want to thank you guys, and I hope you have a great rest of your day.